Okay, let us start the class.
Alright, sure. Is it better, Uncle?
It's better now.
Alright.
We were doing
We were doing an exercise on Uncle.
we were doing
8.2.
exercise 3. I told you you can do as homework.
Yeah.
Okay, let me put that. Sorry, exercise 8.2. 3 is homework. Let us do the fourth sum now.
Oh, okay.
The probability of somebody is outside. And just tell them to move.
Sure.
Class is happening. Just 1 second. And talk here. Speak loudly.
Okay.
Probability of solving a specific problem independently by A and B are half and 1/3 respectively. You both try to solve the problem independently. Find the probability 1 and the problem is solved. So any one of them is solved. That means it is A union B. Let us do this problem straight away. Just join my. I just finished a conference and I'm coming out. I'll have to get the graphics tablet in place. That's all. 2 seconds. Okay. Now, exercise 8.2, fourth sum. Okay. The probability of solving a specific problem independently, P of A is equal to half. Then P of B, that B will solve the problem. Okay. That is 1/3. Yeah? Independently. These two are independent. Okay. You both try to solve the problem independently. They are independent events. It's very important. They are independent events. Okay. Now, how to find out the problem is solved? You have to find out P of A union B. Okay. Problem is somehow solved. That is P of A union. Why? Because either A will solve it or B will solve it. You understand why it is P of A union B?
Yeah.
First thing is asking find P of A union B. But actually how it is solved? Asking find the probability the problem is solved. Okay. Second one is asking find the probability exactly one of them will solve it. Okay. That will be P of A will solve it and B will not solve it. Union P of A will not solve it, but B will alone will solve it. Okay. This means A solves, B doesn't. That means only A solves. This means only B solves. You understand? But what is he asking? Exactly one of them solves. So that means either A only solves, or B only solves.
Okay.
This is the interpretation from the real world of English into the probability world of set theory. You understand?
Yeah. On the arrow
you
sum
there?
madri da.
Hello?
Yeah. Yeah, uncle. It's like
James?
the arrow sum only, no?
What happened, James?
Uncle, can you hear me?
James, are you
Hello.
there?
Yeah, uncle. Hello.
James?
Hello. Uncle, can you hear me?
James, can you hear me?
Yeah.
You're logged in, but I'm not able to hear you. James, but I'm not able to hear you. What happened?
This thing is on only,
Your mic is
microphone.
not proper. It's not working.
1 minute, uncle. Better, uncle?
Can you adjust your mic?
Uncle, it's full maximum.
I'm not able to hear you. Okay, I'm assuming you are hearing me. Get a nice system, boss. Get a good laptop, good phone system, everything. See, I'm doing my best. I upgraded my system because the previous system was hanging. So I upgraded it. I put an SSD drive. I doubled my RAM, and now I'm going to give you a very good session. Everything I have the best tablet. Like that, you should also have the best laptop and best configuration in order to learn. If you come like this, then we will not be able to do a good session. I don't know what to do. Can you reply on or text me also? Text me on WhatsApp at least, whether you are able to hear me. I'm not able to hear you completely. If you want to log out and log in, that's also fine. James, can you text me? Are you there? Or you want to log out and log in? Hello? I'm not able to hear you. No, can you speak now? Hello? James, can you speak now? No. I think I can hear you now. Speak. Okay, it's gone out. I don't know how my thing got muted. Okay. Okay. It's taking a long time. Okay. Fine. Okay, now let us go to the problem now. So what we have now is P of A is independent, P of B is independent. No? So you understood what he's asking. First thing he's asking is find that somehow the probability that the problem is solved. That means either A will solve it or B will solve it. Okay, this is P of A union B you are asked. Okay. Then the other one you are asked is P of A solves it and B does not solve it. Or A alone solves it, B does not solve it. Okay, so either only one of them solves it. Okay, it's very important.
Okay.
Okay, some noise is coming. I don't know from your end. Now, what you have to do? You have to find P of A union B. Now, P of A union B, we have only independent events here. So we can only do P of A into P of B is equal to P of A intersection B. So only intersection formula you can apply here. So how do you use A union B? Now that is equal to 1 minus P of A union B, the whole knot. Okay, that is equal to 1 minus P of A naught intersection B naught. Okay, this is the way to do it. Now you have got a intersection. From union you have changed to intersection. Okay, from union you have changed to intersection. Okay. Now what you have to do? So find P of A intersection A naught intersection B naught. That is equal to P of A naught into P of B naught. A bar into P of B bar, or A complement to P of B bar. This is A naught. Okay. So what is P of A naught? That is equal to 1 minus P of A. What is P of B naught? That is equal to 1 minus P of B. Okay. 1 minus P of A is equal to 1 minus half. That is equal to half. This is half P of A. Okay. 1 minus P of B same way is equal to 1 minus 1/3. That is equal to 2/3. Okay. Now therefore P of A naught intersection B naught is equal to P of A naught into P of B naught. That is equal to half into 2/3. That is equal to 1/3. Okay. So this is equal to 1/3. Now what we need is 1 minus P of A intersection B intersection. So P of A union B is equal to 1 minus P of A intersection A dash intersection B dash. That is equal to 1 minus 1/3. That is equal to 2/3. So the probability that it will be solved by someone, either A or B. Okay, it's equal to 2/3. This is one part of the sum. Okay. Now the other part of the sum is P of A intersection P of B. Okay. So P of A intersection B dash is equal to P of A into P of B dash. Then P of A dash intersection B is equal to P of A dash into P of B. This is equal to P of A is how much? Half. P of B dash is equal to how much? P of B dash is 1/3. 2/3. Okay.
2/3.
So that is equal to 1/3. Same way P of A dash is equal to P of A dash is half.
1/2.
To P of B. What is P of B? 1/3. P of B.
1/3. Okay.
So 1/6. Okay, you got that. Now you have to find union. Union here is it is only plussing. Okay, P of A intersection B plus P of A intersection A dash intersection B. That is equal to 1/3 plus 1/6. That is equal to divided by 6, 2 plus 1. That is equal to 3/6. That is equal to 3/6. You simplify, you will get half. Okay. So probability only one will solve the problem. Okay. Only one of them at a time will solve at a time. It's equal to half. Okay. These are the two things that are given. You understood, no?
Yeah.
Now, why you may ask P of A intersection B, this one union this one, why you are giving as plus? Why you are making that union into a plus here? Okay. So that is very important because they are mutually exclusive events. Okay. Only A solves a problem, only B solves a problem. Mutually exclusive events.
Okay.
If A only solves a problem, mutually exclusive. Sorry. If A only solves a problem, B is not solved it, correct? If B only solves a problem, then A is not solved it. So they are mutually exclusive events. In mutually exclusive events, P of A union B is equal to P of A plus P of B. You remember? This is from 9th standard.
Yeah.
9 standard. So that is why I'm just adding up. If they are not mutually exclusive, then you have to do P of A intersection B. Okay, this is the full formula. But if they are mutually exclusive, then this becomes null set or this becomes 0. So you are left with P of A plus P of B. Same way, if there are 3 are mutually exclusive events, then they are equal to P of A plus P of B plus P of C, like that. It will keep on going. Any 3, 4, 5, 6 events are all mutually exclusive. Then the union of those events is equal to A, P of A plus P of B plus P of C, like that. It will keep on going. All right. I'm going to post this in your WhatsApp. So fourth sum is over. Fourth sum, nice sum. Huh? Then we have to take fifth sum. Fifth sum is some stupid sum actually. It's got nothing to do with your current portions. Okay. Saying,
Okay.
but you still have to do it. If it comes, you can do it. Not a big deal. Let us delete this. Now, exercise 8.2 sum. Sum. Suppose one person is selected random from a group of 100 persons who are given the following table. Okay. Now he is given men, women, total. Then this side is giving psychologist, then socialist. It's all stupid sum. What is psychologist got to do with socialist and Democrats? Democrats and socialists are political categories. This is a scientific category. So some stupid people are forming some stupid sums. Okay.
This
so
is
in
India,
spite of
uncle.
all this, we are learning. This fellows who are setting your syllabus, they have said some nonsense. Okay. Now, how you get 100? 15 men are psychologists, 25 men are socialists, and 10 men are Democrats. So totally 50. Then 20 women are psychologists, 15 women are socialists, 15 women are Democrats. That is also 15. The total number of psychologists, total number of socialists, total number of Democrats given. Okay. Now all this is useless. So much data they did not give. What is the probability the man selected is a psychologist? Okay. If you take n of s, if you take sample space as only men, then n of s is equal to 50. Sorry, 50. If you take sample space as all the people, then n of s equal to 100. Okay. Your textbook answer is implying that what is the probability that the man selected among the men is a psychologist? Okay. The number of favorable events for psychologist. Okay, n is 15. Correct. So probability of psychologist is equal to n of psychologist by n of s. That is equal to 15 by 50. Okay, divided by 5, 3, divided by 5, 3, and that is equal to 0.3. That's all answer. If it is taken as 100, then it will be 0.15 because 15 by 100. Okay, you will get. So you take this answer, you leave out that answer because your textbook is implying that out of the men, so many people are taken. Okay, this is a silly problem. If you get it in your thing, don't attempt it.
Sure.
Okay, this problem, I don't like it. It's not a properly formatted, properly given thing. Okay, let us go and do sixth sum. This is better. Okay. Two earns. This is a real problem. problem. Two urns contain the set of balls given in the following table. Urn 1, urn 2. Okay, white, then red, then black. Okay, 10 balls in the 6, 9, then 3 balls, 7 balls, and 15 balls. One ball is drawn from each urn and find the probability that both balls are red and both balls are of the same color.
Uncle,
Okay.
what is on, Uncle? How to picture that?
Jadi.
Jadi na? Bag,
Pot.
Oh, pot, okay.
That's all.
Porcelain pot.
Porcelain pot.
Where you store pickles.
So you store your pickles and all here, no? Those kind of porcelain pots. Okay, those are only urns.
Okay.
So urn means don't think something. Chumma, it is a container. You put it at pot or whatever, same thing only. So inside that urn 1. Okay, one ball is drawn from both balls are red. First, let us deal with the condition both balls are red. Okay. Now P of urn 1. Okay, let us deal with that situation. Okay, P of urn 1. Number of favorable cases are red is 6. Total number of cases 10 plus 6 plus 9. N of S we can put here. N of S will be 16 plus 9, 25. So the probability of picking red ball from urn 1 is 6 by 25. Probability of picking red ball from urn 2 is what?
Both balls are of the same color.
There are 7. Okay, favorable cases are 7. Then total number of cases is 15 plus 7, 22. 22 plus 3 is also 25. So 7 by 25. Okay. Now individually you take from first urn is 6 by 25. You take from second urn red ball coming is okay. This is also red ball coming. This is also individually red ball coming. Both are red ball means P of urn 1 intersection P of urn 2. Okay. Red ball coming from here, red ball coming from the second 2 parts.
Understood.
So idilano red ball varudhu, idilano red ball varudhu.
Red ball.
Okay. Now what you have to do? You have to take intersection because intersection means both and. Both first urn and second urn have red balls. That's the meaning. Okay, U1 intersection U2. Now, what is the multiplication formula? P of U1 into P of U2. Why? Because U1 and U2 are independent events. So, multiplication law works. Multiplication theorem works. So, use multiplication theorem. What is multiplication theorem?
Okay.
If the events are independent, then P of A intersection B is equal to P of A into P of B. Remember?
Yeah.
This is the multiplication theorem. That only you are applying here. So that is equal to 6 by 25 into 7 by 25. That is equal to 42 by 625. That's all your answer.
Okay.
Okay. Now, both the balls are red. That is the answer. Now, you have to
Both the
do
balls
other
are
part
of
of
the
the
same
sum.
color.
Other part of the sum you have to do.
Yeah.
First, let us post this. First part is over. Let me erase all of this. Both balls are of the same color. You have to find out. Both balls are of the same color. See, this one is 42 by 625. Let us retain that. I will tell you why you should retain that. 42 by 625. Okay, both balls are red. It's 42 by 625. P of R1 intersection R2, you put like that, is equal to 42 by 625. Okay, now you have to find out both balls are of the same color. That means it can be either, it can be either both are red or both are what? White.
Same.
Or
Black.
can be both are black. So either or means you have to find out P of W1 intersection W2. Then you have to find P of black 1 intersection black 2. Okay, you have to find it. And then because it is either or, the final formula will be P of red 1 intersection red 2 union P of white 1 intersection white 2 union P of black 1 intersection black 2. Why union? Because it is either or. Okay. You understood? Whenever either or comes, you have to do union. P of either A or B means P of A union B. So either R1, R2 or W1, W2 or B1, B2 means P of R1 intersection R2 union P of W1, W2 union P of B1, B2. Okay. But individually, each of these are intersections. Why? Because individually, both balls have to be intersection means both and. Okay, this intersection is both and. Okay, both first urn is red ball and second urn is also red ball. Understand? Same way,
yeah.
Both first urn also giving black ball, second urn also giving red black ball. That is intersection. Same way, this intersection means both first urn is giving white ball, second urn is also giving white ball. Okay. Now you understood the problem. First thing is, the only thing with probability is how to turn the real world statements. Okay. How to turn the real world statements into statements inside the set theory for probability. Okay.
Yeah.
That's all the whole matter is. There is no other matter to it. Everything else is very, very preliminary calculation. Okay. Now let us find out W1 intersection W2. Okay. What is W1? That will be n of white 1 divided by n of S1. That is equal to white 1. How much white in urn 1? 10. 10 divided by 25. This is 25 n of S. Okay. Into the second one. How many white are there? 3 are there. 3 divided by, what is the total sample space? 25. Okay. That is equal to 30 by 625. This is 2. First one is 42 by 625. This is 30 by 625. Third one is blacks. How many n of black is? N of B1 divided by n of S1. That is equal to black is 9 divided by 25. What is black in urn 2? B2. Okay, how many blacks are there? 15 are there. Into 15 by what is the n of S2? 25 again. Okay, 25. So 15 into 9, how much?
15 into 9.
135. That is 135 by 625. Okay. Now what you have to do? I told you P of all these three union. Union means they are all independent events. I mean, they are mutually exclusive events. Okay. If you pick 2 balls are red, then automatically the 2 balls are not white. So if you pick 2 balls are white, automatically the 2 balls are not black. So these 3 are mutually exclusive. Therefore, this is equal to P of R1 intersection R2 plus P of W1 intersection W2 plus P of B1 intersection B2. Okay, black 2. So is equal to this plus this plus this. That is equal to 42 plus 30 plus 135 divided by 625. Okay, 135 plus 30 plus 42. 7, 4, 10, 207. That is equal to 207 by 625. This is the probability that same color balls are drawn from both ends. Probability that same color. Okay, that's all. You understood this thing?
Yeah.
So 8.2, this is sum number 6. Sum number 6, very interesting sum. If it comes, you please attempt it. I'm going to post this in your WhatsApp. I upgraded my RAM, everything, man. That's why it's now working
Faster. Okay.
Otherwise, it was hanging. This graphical software, graphical software is highly intensive, so it was hanging. Now we are going for Bayes theorem. Sum number 7 is what? Bayes theorem. Okay, I'm going to do sum number 7, and maybe sum number 8 you can do, because that's also
Okay.
Bayes theorem. Okay, take 8 for homework. Sum number 7 I do now.
So 3 and 8.
3 and 8 homework. Sum number 7 I do now. Exercise what? Exercise 8.2. Bag 1 contains 3 red and 4 black balls, and bag 2 contains 5 red and 6 black balls. Okay, now event 1 is choosing bag 1. Event 2 is choosing bag 2. Okay, only 2 bags are there, so your problem is very easy. One ball is drawn at random from one of the bags. Okay, ball drawn. Find the probability it was drawn from bag A. That means you have to find that a ball is drawn, red ball drawn. Okay, red ball is drawn. Find the probability that given that you have drawn a red ball, it was actually got from bag 1. You understand? This is what you have to find. You have to find. What is the formula? P of E1 by A is equal to P of E1 into P of A by E1 divided by sigma. Sigma means P of E1 into P of A by E1 plus
P by E2
into
plus P by AE2. Yeah.
Now what do you know? E1 bag 1 P of E1 is what? Only 2 bags. Either you can choose bag 1 or you can choose bag 2. So P of E1 is equal to half, P of E2 is equal to half. Okay. Now we have to find out what is the probability of P of A coming from E1. Okay. You put your hand inside bag 1, then how will you get a red ball? That is what you're asking now. You understand? Once you have put your hand inside bag 1, can you draw out a red ball? What is the probability that you're asking? This is P of A by E1. You understand? Having put your hand inside bag E1, what is the probability that you will draw a red ball? That is only P of A by E1. So how you have to find that out? Bag 1 contains 3 red balls and 4 black balls. Okay, that means 3 plus 4. 3 by 7. This is probability A given E1 is 3 by 4. The other one is probability A given E2 you have to find. That is, you put your hand inside bag 2, what is the probability that you will draw out a red ball? Okay, you understand? Okay. So bag 2 contains 5 red balls and 5 plus 6. Okay, total number of balls. So 5 by 11. Okay, this is the probability. Now you know all the 4 values you are needed. Now you can start substituting in the formula. P of E1 is how much? Half. Half into P of A by E1 is equal to 3 by 7 divided by, again P of E1 into 3 by 7 plus now P of E2. How much P of E2?
P of E2, 1 by 2.
P of E2 is 1 by 2. Half into P of A by E2?
A by E2, 5 by 11.
5 by 2. That is equal to 3 by 14 divided by 3 by 14 plus 5 by 22. Okay. Now multiply this by 7, multiply this by 7. 21 by 154 divided by, why I am multiplying? Because this common LCM for this is 154. Okay. This is 14 into 7. 4, 7, no. Wait, 22 into 7. 14, 2 7s, 154. Okay. Yeah. So this will go, 14 will go in this, 22 will go in 7 times. So 5 will go 7 times, this is 35. Okay. 14 will go in 144. How many times? 14 into 12, 11, 11, 14 plus 140, 154. Okay. 14 goes 11 times. So this is into 11, this is into 11. So 3 into 11, 33. Okay. Cancel both of this. You get 21 by 35 plus 33.
35 plus 33.
68. 21 by 68. So that is your answer. P of E1 given A is equal to 21 by 68. Okay. 7 sum. Any calculations problem? Any mistake I have made? By 14 is correct. By 14. Yeah, it's correct. 68. Let me post this in your. Seven sum. 8 sum you can do as homework. 8 sum you can do as homework. Let us try. It's also 9 sum. Okay, but we'll do class work because there are 3 now. It's getting complex. It's getting complex. There are 3 boxes, B1, B2, B3. They contain lamp bulbs, some of which are defective. Okay. So the defective proportions in box B1, B2, and B3 are half, 1/8, and 3/4. Okay. So 3 boxes. We should assume each of them are having equal number of lamp posts. Okay. So E1, E2 is box 1 and E3. P of E1 1/3, P of E2 1/3, P of E3 1/3. Like that you should assume. Okay, equal number of bulbs are there in each of the boxes. Okay, same type of box. Now the probability of defects. Okay, now let A be the defective bulb. You're picking a defective bulb. Event A. Okay, now the probability of entering your hand into box 1 and picking a defective bulb. Okay, this is P of A by E1. Stelling is given as half. Then the probability of putting your hand into box 2 and picking out a defective thing. He is giving us 1/8. Then the probability of putting your hand into E3 and picking out a defective bulb is given as 3/4. Okay, this data is given. What you have to do is interpret this data. Now all of the things necessary is given. So what you have to find out, what is the probability that box B1, okay, is picking a defective bulb. What is the probability that you picked up a defective bulb from box B1, from box 1, okay, equal to what? That is equal to P of E of 1 into P of A given E1 divided by what you have to do? P of E1 into P of A by E1 plus P of E2 into P of A by E2 plus P of E3 into P of A by E3. Okay, now substitute all the values. How much is E1?
E1 1/3.
1/3, correct. E1 is 1/3. Okay, so 1/3 into P of A by E1.
P of A by 1/2.
Yeah, 1/2. Again, P of A, E1, same thing. Now, P of E2.
P of E2 1/3.
1/3. P of A by E2.
1/8.
1/8. P of E3.
1/3.
A by E3.
3/4.
Very good. Okay. So that is equal to 1/6 divided by 3 and 3 will go 1/6 plus 1/24 plus 1/4. So take 24 as a denominator, multiply this by 4, this by 4. Okay. So 4/24. Numerator 4/24. Denominator is also 24. This will go 4 times. So this is 4 plus, this will go 1 time, plus this will go 6 times, plus 6. 6 plus 1, 7. 7 plus 11. Okay, that is equal to 4/24 divided by 7/24. Cancel 24 and 24. Your answer is 4/7. This is P of E1 given A. So the probability of picking a defective from box 1 is equal to 4/7. Sorry, 4 by not 7, 4. 6 plus 1, 7. 7 plus 1, 11.
Yeah.
4/11. That is a sum. Okay. You got that 9 sum. So that's very important sum. 3 are given. That's why it's slightly more complex. That's why I did it.
Yeah. Okay.
8 sum homework.
Yeah. 3 and 8.
3 and 8 homework. 9 sum is done. This is also Baye sum. 3 horses on a race. A is twice as likely to win. Okay, this is not Baye sum. You do it as homework then. A die is thrown, probability of getting a prime number, a number greater than or equal to. This is not Bayes problem. These are all simple 9th standard problems. Okay, 10th and 11th sum are simple problems from 9th standard level. So 10 and 11 it's not Bayes problem, it is simple probability issues from 9th standard level. Okay, use 9th standard probability to solve 10th and 11th problem. No, they are very easy.
Okay.
Now let us look at the 12th problem. I think we should do 12th problem. Yeah. cards are numbered 1 to 10, are placed in a box, they mixed up thoroughly, then one card is drawn randomly. Okay, this is also not Bayes' theorem, but let us do it. Move all this. Let's do the 12th problem. Sample set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, one card is drawn randomly. It is known that the number on the drawn card is more than 4. Okay, now the new sample set is more than 4. 5, 6, 7, 8, 9, 10. Original n of s is equal to 10. Let us put this event. It is known that the number on the drawn card is more than 4. More than a 4 is drawn, then n of a is equal to 1, 2, 3, 4, 5, 6. 6. Okay. It is known number on the drawn card is more than 4. What is the probability that it is an even number? Event B is an even number. Okay. Event B is 2, 4, 6, 8, 10. Okay. Now A intersection B is what? This 2 and 4 won't come. 6 and 6 are there. 8 is there. 10 is there. Okay. So A intersection B is equal to 6, 8, and 10. N of A intersection B is 3. Okay. Now, so P of A intersection B is equal to 3 by total N of S is 10. Okay. These are the favorable events, number of favorable events to the total number of events, P of A intersection B. Okay. Then, what is asking to find? What is the probability that it is an even number? What is the probability that it is an even number given that already, okay, event A has occurred? What is event A? Something more than 4 has occurred. You understand? Number more than 4 has been chosen. This is event A. Event B is conditional on event A. This dash means event B is conditional on event A. So already a number greater than 4 has been chosen. Now the probability of it is being an even number given that already more than 4 has been chosen. Okay, that is what you are going to find out. That is equal to P of A intersection B by P of A. You remember this formula? Conditional probability formula. That's all you are going to do. Okay, this is a conditional probability sum. 12th sum is a conditional probability sum. Okay, 12th sum is a conditional probability sum. You have to use the formula. This is formula. Okay. So P of A intersection B is 3 by 10. P of A is how much? P of A is equal to N of A by 10. Okay, this will be 6 by 10. Cancel 6. That is equal to 3 by 6. That is equal to half. Okay, 12th sum will be half. So the probability of it is an even number. Given number is already greater than 4. Is equal to half. Okay. So this is 12th sum. This is a simple sum. This is not Bayes' theorem. Bayes' theorem is slightly more complex, but Bayes' theorem is very clear. Bayes' theorem. Okay. All you have to do is put the things in the correct place. Find out E1, E2, E3. Don't give complex names. That fellow will confuse you by saying E1, E2, E3, and then instead of A, he will give you E. Okay, or E4 he will give you. Don't get confused. You change the names, always put E1, E2, E3, E4, and then the arbitrary event which is not connected with that, you name it as A. Then you will always have no problem. See, for example, you will give machine is A1, A2, A3. You don't put A1, A2, A3. You always put E1, E2, E3. Okay, rename. Let machine A1 be E1. Let the probability of a bolt being produced by machine A1 is E1. Okay, P of E1. Then probability that the screw is manufactured by machine B is or A2 is E2. Like that, you change it so that you will always get in terms of E1, E2, E3 up to En, and then the arbitrary event will always be named as A. You always name it as A. Then you will not have any confusion. This fellow will try to confuse you by giving the different names for the event. That is why you have to spot what are the mutually exhaustive events and exhaustive events E1, E2, E3, E4, and what is the arbitrary single event that is A. Okay.
Yeah.
That's all. Once you find that out, give the correct name. Don't go for the names that are given in the problem. You always choose E1, E2, E3, or E4 and En, and always choose for the arbitrary event. You give the name A and then solve it. It will be very easy then. So this fellow will confuse you. You change the things and you put it in your sum like that.
Sure.
Okay, 12th sum is over. You can put it here.
Okay. And Saturday we have evening class only, uncle.
Saturday we have
evening class. We'll have it in the evening.
That means we allowed to have it 6 to 7.
6 to 7. Okay, uncle. That will do.
Because you are doing a morning exam, you can't do it 2 to 3 like that.
2 to 3 I have school.
3 to 4.
3 to 4 school.
Oh, okay. 6 to 7 only then, because
yeah.
4 to 6 I have that conference. I have to go.
Okay. Sure,
6 to 7 we'll do like this today itself.
Yeah. Sure, uncle.
Okay. Now 12 sum is over. You have to do 13 sum.
13 sum.
13 sum also is not okay. Conditional probability sum.
We have only 3 minutes, uncle.
3 more minutes. We finish 13 sum. You can try to do. Ah, 15 sum you can do is simple sum. Yeah, 15 sum also homework. 16th we'll do in class. That is a Bayes theorem sum. 15th we'll do in class, Bayes theorem. 16th. 15th you finish. So that next class we'll finish probability. We'll finish probability. Now let us do 13 sum, 3 more minutes only. We will do it very fast. Thousand students. N of S is equal to 1000 students. Out of which 450 are girls. Okay, N of G is equal to 450. So probability of a girl is equal to 450 by 1000. It is 0.45. Okay, that is possible. Okay. It is known that out of 450, 20% of the girls are studying in class 11. Okay. What is the event A that has happened? It is known. It is known means event A has happened. Okay. 20% of the girls. That means 1/5 of the girls are studying 11th standard. That is the event. Okay. Now, what is the event B? Student selected. From 1000 students. What is the probability the selected student is from class 11? Okay. Student selected or girl is selected. Student selected. Okay. Student selected is from class 11. Given it is a girl. Okay. So, it's a girl that is selected. 1/5 of the girls are studying in 11th standard. So the probability of girls is equal to even studying in 11th standard. Probability of total probability of girls is of being girls is 0.45. Okay, then that into 1/5, 0.09. Okay, so 0.09 is probability of girls studying in class 11. So it is a girl which is studying in class 11. Okay, how many? Okay, out of 450 girls, okay, only 1/5 are studying in 150 are studying in class 11. Okay, that means 90 girls in class 11. 90 girls are studying in class 11. Okay, now he's asking which we will take as A, which we will take as B. Let us take N. A is equal to 450 girls. Okay, probability of A is 0.45. Let us take B as A intersection B as girls studying in 11th standard. B as girls in class 11. Okay, that is equal to 90 students. Okay, 90 divided by 1000 equal to 0.09. Girls studying in class 11. Now he's asking what is the, given that the student is a girl. Okay, given that the student is a girl, what is the probability that it is from class 11? Okay, the student girl is from class 11. B is girls in class 11. A is number of girls. Okay, so this is a girl. Girl is chosen. That means from event A. Okay, then the girl chosen is from class 11. Okay, somebody is chosen from class 11 is B. The girl is chosen from class 11 is girl is chosen, and from class 11 a student is chosen. Okay, so that is a probability of B given here. That is P of A intersection B divided by P of A. Okay, P of A intersection B is 90. Okay, because total number of girls were 450. Okay, number of girls who are in class 11 is 90. We found that out. 90 girls in class 11. Okay, so N of A intersection B, N of A intersection B by N of S divided by N of A divided by N of S. N of S will cancel. That is N of A intersection B by N of A. That is equal to 90 divided by 450 equal to 1 by 5 is equal to 1 by 5. So probability of B given A is 1 by 5. All right, or you can write it also as 0.2, whichever you want. 1 by 5 is enough.
Yeah, sure.
Okay, this is also conditional probability problem. So when you see the problem itself, you must be able to see whether it is a Bayes theorem problem or it is a conditional probability problem. Okay, how will you recognize it is a conditional probability problem? You will say that, okay, it is already known that out of 450, 20% of the girls are studying class 7. Something is already known means A has happened. Already known means A, or A has already known or happened. Okay, So A is what already happened. 20% of the girls are studying in class 11, like that. Okay, like that you have to take. In fact, this is correct. Already known that the girl is chosen is A. What is the probability she is chosen from class B, class 11? That is the probability there. Okay, this is also slightly confusing problem, conditional probability problem, but I think we have entered the time. If you have any doubts, we'll continue in the next class.
Sure.
Okay, already exceeded 5 minutes.
Yeah, uncle.
Okay, I think we are done now. We see
Yeah.
you on 6 o'clock at Saturday.
You said tomorrow, uncle, because next Thursday you won't be coming.
Tomorrow,
Tomorrow we will see, uncle. Otherwise, we'll push it to Monday.
oh, you are talking about this session. Oh, not tomorrow. Tomorrow I can't do. Tomorrow holiday, no. I have
Yeah.
program holiday. We have to do it on Saturday evening 6 to 7. Otherwise, you'll
Okay.
push it on Monday morning.
Yeah, sure, uncle. The Saturday class, no?
Saturday
said-
class only, I'm saying.
Yeah, okay.
Saturday class, we'll push it to Monday morning. Huh?
Monday morning.
Why don't we have it on Saturday 6 to 7? Not possible. Evening.
Saturday 6 to 7 is possible, uncle. Yeah.
Then we'll do it 6 to 7
Yeah.
Saturday.
Yeah. But you told next Thursday you're going out now.
Next Thursday I'm going out.
Yeah.
That thing we have to take it on a different day. That we'll do
Okay.
afterwards.
Sure, uncle.
Okay.
Okay.
This Saturday 6 to 7 we'll do.
Sure.
Okay. So Saturday 6 to 7, same time we are meeting. Okay.
Sure.
Don't confuse next week.
Yeah.
Next week, Thursday, I won't be there. That's why I'm asking.
Sure.
Okay. Thanks, man. Bye-bye.
Thanks, uncle. Bye, uncle. Good night.
Good night.